Hey everybody, PCB Junkie back with another video. Today we're building a supergun. So what is a supergun? Well, according to Wikipedia, it's a device used to play arcade games without the need for a full arcade cabinet. Right, so it's a device for playing arcade games, and you may or may not know, but I'm a huge fan of video gaming, and especially arcade games. I have a huge collection, probably over 200, maybe 300 different arcade video games. I don't have too many cabinets, but I have a pile of arcade PC boards that I normally use to entertain myself, and yeah, I really enjoy the hobby. Well, the reason I pulled up this Wikipedia article is because I was curious to see where this term originated, but unfortunately this article does not mention anything about it. I assume it's got something to do with maybe the original manufacturer. They just called the device a supergun and the name stuck, and this name has been used ever since I remember to describe a device like that. So anyway, it's not a difficult project. We'll go through what's needed, and you know, how to put one together, and yeah, get you into some arcade gaming possibly. All right, so yeah, let's go over the things we'll actually need to put this project together. So the first thing we'll need for a project like this is an enclosure box or project box. This thing is just a little bit bigger than my hand, about 2 inches deep, I would say 4 inches tall, and about 7 inches wide. It has to be big enough for a few things. First of all, it has to be able to contain a power supply. So we'll talk about this in a second, but obviously the box needs to be big enough for a power supply like that. Second, you have to be able to attach a 56-pin connector like this. Okay, so we'll talk about this in a second as well. And there may be some other circuitry or some other jacks that you may want to attach, so just make sure that it's big enough, basically. And this one here came from a local electronics store. Cost me about $15, and a box like this can be found on eBay or AliExpress as well for not too much money. Okay, next up is a switching power supply. So we'll need that to power the board. This is an ATX, a former ATX power supply. I pulled it out of its shell. It's fairly beefy. It's fairly large, and you'll need one that can supply 3 rails, plus 5 at about 10 amps or so, plus 12 at about I would say maybe 2 amps. 1 amp at least, and a minus 5 rail at about 1 amp as well. Okay, and that's a recent standard, and most games, I would say 99% of the games, will use at least the plus 5 and the plus 12 rail. Some will also require a minus 5 rail, but that's less common. Important thing to remember with ATX power supplies is that after about 2003, the ATX spec changed, and the minus 5 rail was removed from the specification. If you get a recent power supply, well, it will not have the minus 5 rail, most likely. This one does. This one's been used for a while. It's fairly old. I already have a terminal block attached to it. I've been using this one for some crypto mining in the past, so I'm no longer doing that, and of course I'll just reuse whatever's attached here. It also has a switch and a plug that we can just simply reuse. So if you don't want to use an ATX power supply, you can get just a basic JAMMA or basic arcade power supply that would cost you about $15, and you can get one of those from eBay or AliExpress. They're fairly common. Next up, we talked about this briefly already, but let's just go over this in a little bit more detail, is a 56-pin edge connector, a female connector. Now this is a 3.96 millimeter connector. You can get this from eBay or AliExpress. Just look for JAMMA or 56-pin 3.96 millimeter type connector. It'll look something like this, and this is how the game interfaces with the cabinet typically, and of course we'll use something similar in order to power up the game and also interface with the game's controls. Okay, so that's that. Next up is a way to we'll need some sort of a way to connect a controller. So what I have here is some DB9 connectors. We'll be using these to connect to a Genesis controller. So Genesis controllers are actually fairly good for this. They're pretty straightforward, and in the simplest form, they can be used to input our up, down, left, right, and our 2-button inputs. Okay, and in I would say the majority of the cases, that should be enough. Most arcade games only use 2 buttons. Some will use 3. With Neo Geo and Street Fighter type games, you have to have 6. But we're not going to go for that. We're not going to go for a 6-button control. First of all, well, we'll talk about that later, but it gets a little bit more complicated. What we will do here, however, is to use an Arduino and interface to a Genesis controller to get its 4-button mode. So that would be the A, B, and C buttons, as well as the start button. Okay, so that will get us the 4 inputs, and it's just a little bit more difficult than just wiring this straight to the board for the 2-button mode. Okay. Next up, we'll need some buttons. So I got a couple of momentary buttons here. I got a black one and a red one. These are going to be needed to send the coin input to this connector to coin up the game and also to start it. Okay, so I got 4 of these for the 2 coin inputs and also for the 2 start buttons. And last but not least, I have here an RCA terminal, a small little panel with 4 outputs. Because I have an RGB TV, I'm going to be using these to send the RGB signal to the TV, and I'll use the last one for sound. Okay, so if you don't have an RGB TV, your only other options are YUV or component inputs. This gets a little bit more difficult. We'll talk about that, but we won't be doing it in this project. This is strictly for an RGB output. Okay, but I'll make another video maybe on how to get a component output out of an arcade game. And other than that, just need a couple switches for power and a way to send power to this enclosure, and I have here an IEC plug which I'll be using for that. So that's pretty much it, and I don't think I've missed anything. So let's talk about the arcade games, the type of games that are out there, and also what the recent JAMMA standard looks like. What I have here is a game called Kangaroo. It was manufactured by Sun Electronics and distributed by Atari. It's a fairly decent game. I mean, it's not a favorite of mine, but it's fairly decent for 1982. and also a fairly common game. This is what a typical board looked like in those days. There was a bunch of 74 series logic. I had some custom sound ICs. You had maybe a couple of processors. I believe this one has two Z80s, and just a number of ROMs, 27 series typically. Back in those days, the way that the game would interface with the cabinet would vary quite a bit from game to game. Every manufacturer did pretty much whatever they wanted, and it mainly depended on the type of controls that a game would use, the type of monitor that the game would use. So in those days, you know, there were a lot of different types of controls. You had the various analog controls, analog joysticks, paddles. The monitors would also vary sometimes. You could get a raster, either color or monochrome, or a vector monitor, again, either color or monochrome. So there was quite a bit of variation, and like I said, every manufacturer did pretty much their own thing with how the game would connect to a cabinet. So this one, as you can see, has two edge connectors. The top one is a 44-pin edge connector. It's used to supply the power into the top board, and then the controls were out here along with you know, the coin controls and the counters and all that. The bottom board is a video board. So again, it has some power pins. This one actually very clearly labeled. It's pretty unusual, and also that's where the video would come out of. So you'd need two connectors in order to wire this game up. It's still possible to play a game like this, but obviously you need to do a little bit of conversion if you want to connect it to a more recent cabinet or a supergun device. We can talk about that later. I may make a separate video on that topic. But like I said, yeah, this is an early board, and the standard for early boards, well, there are no standards. Each board pretty much has a unique pinout, and you'd have to find out what it is and wire a game like this accordingly. Here's a second board I want to show you. This is a Nintendo Versus System board. The purpose of this board was to bring low-cost arcade gaming to arcades. Nintendo wanted to use this type of hardware to retrofit existing Nintendo cabinets. The one thing that's unusual about this game, or this game board, is that it can actually run two games simultaneously. So we have a side here that can run one game, and then the other side can run another. This hardware is very closely based on the NES hardware, and as you can see, this game used to run Excitebike. So a lot of the games that are available on this hardware are basically ports of the NES games, which is kind of unusual because typically an arcade game was released first and then it was ported to various consoles. But the system does it backwards. If you noticed, this board also has two connectors. There's a 44-pin connector right here, and also I believe that's a 36-pin connector. And like I said, this one is able to run both games simultaneously. There were Versus cabinets with two monitors. Some games could be played co-op style, like tennis. Tennis was a 4-player game. I think for tennis, both sides of the ROMs had to be populated, and there was some sort of a way that the board would communicate back and forth to make sure that the two sides of the cabinet were in sync. The problem with a board like this, on top of having two games running in parallel, is the fact that the monitor output is inverted RGB. So typically in a regular game, a 0-volt signal would mean black, and you know, a 3+ volt signal would mean a very bright color. This game does it backwards, so it's 0 means very bright, and then, you know, 3+ volts or whatever the peak is would be a black, right? So not compatible with the recent JAMMA standard, not compatible with most cabinets, but that's because this particular board was intended to go into an existing Nintendo cabinet, which had monitors that accepted inverted video. And yeah, in order to play a game like that, you would have to build yourself an adapter and also a video inverter. I've done a little bit of work on that, and I'll show you maybe in a later video how to play a game like this in a JAMMA cabinet. But yeah, again, this is one of those unique boards that just has a weird pinout, and I thought I'd go over that and mention that sometimes things can get a little tricky. Now, this is a more recent board. This is actually a bootleg or a unauthorized copy version of Mortal Kombat. This one has some issues with some graphics. I mainly use this as a test board, but this one is released, I believe, in early 90s. I'm not sure, 1991, not quite sure. And it follows the JAMMA specification, which we'll talk about in a second. So all modern games have typically the same pinout. We have our power on the left here, power rails, and then that's followed by speaker output and coin and video, and then the controls for player 1 and player 2. Player 2 controls are actually on the bottom, on the solder side of the board. So this is a more recent game, and games like this after 1987, you would not have any issues playing a game like this on a recent cabinet, or a JAMMA compatible cabinet, or a supergun device. Okay, so anything after 97, maybe late 1996 is a safe bet. Of course, you need to make sure it's JAMMA compatible, and that's what we're focusing on with our supergun device. Well, we're going to be wiring it for JAMMA, and should allow us to play pretty much all of the recent games that have been released in the arcades. Let's talk about the JAMMA pinout standard for a second. So the JAMMA pinout standard uses a 56-pin connector, which I showed you earlier. That's the connector that we're going to be using to hook up to our game, and we'll wire it according to the standard. This standard came about due to the fact that back in the early 80s, it was very difficult for an arcade operator to swap a game. They would normally have to either get a new cabinet, which cost a lot of money, or they would have to rewire an existing cabinet for the new game. And you know, back in those days, pinouts were unique in a lot of cases, and it was quite difficult to do that. So in 1987, the Japanese Association of Arcade Manufacturers, I'm not getting that acronym quite right, but they came up with a way to standardize the way that games would connect to a cabinet from that point onwards. And after this class, or this standard was developed, pretty much all manufacturers followed, and the games released after 1987 pretty much all adhered to the standard. Let's talk about each pin and its function, and I'll tell you exactly what to look out for with each one of these. So at the top here we have our ground and our +5 volt rails. Then following that is our -5 and +12 volts. This section right here is used to power the game. Next in the list is the key slot. That was just a cutout in the pinout itself to prevent the connector from being inserted backwards, upside down, that is. So sometimes the female 56 pin connector would have some sort of an insert, and that would fit into the key slot, and if you try to insert that connector backwards, you wouldn't be able to. So that's what that is for. Next two are the coin counters and the coin lockout lines. The counters are used to tell the operator how many times the coin's been inserted, and the lockout coils are used to prevent multiple coins from being inserted simultaneously. We're not going to be using any of these for our supergun device. That's not really necessary. I mean, you could wire up a counter if you really wanted to, but I just don't see a point. So, and we have our speaker outputs. For that to be connected to a TV, to an amplifier within a TV, we'll have to drop the voltage down so we don't blow the internal TV amplifier. Then we have our video section right here. We have our green, we have our red, the blue, and the sync. Sync is it's a component, or composite, I should say, composite negative sync. So what that means is the sync goes low at the end of the scan line, the raster scan line, and also at the end of the frame. But the horizontal and the vertical syncs are actually XORed together, exclusive ORed. So when both horizontal and vertical go low, the sync signal actually goes high. Not really of much interest for us at the moment, because the TV that I have is actually compatible with this type of sync. So we'll just wire those lines directly into the TV, and that should do it. Now, as I said, I will make a separate video on how to get this video signal to be compatible with a component type TV, but that will be a separate video. Next, we have our tilt switch, we have our test switch, and our service switch. So these are normally required, or they're used to call up the internal game board test function. Some games had the ability to tell you if there was a to see what the input the controls were like. They would generate the sample video signal that could be used to test the connectivity with the cabinet. So you can wire these up just to a switch, and that may be of value to you, but I don't think we need to do this for this project. Next one up is our coin section. So we have our two coin switches. Those are used to coin up the game, and then following that is our start, player 1, player 2 start buttons that would be wired up to those pins, and then our controls, which are the individual joystick directions, and also our 3 buttons. So the way you would activate a switch in any of these pins would be to make contact with ground. So one side of the switch would be wired to ground, and the other side would be wired to the appropriate pin, and pressing the switch would send ground to the pin activating that function. So just want to make sure you're aware of that. And then our NC pins, not connected pins, this actually is part of the JAMMA standard, but more recently these have been used to wire up button 4 and button 5, and that would be the case in, for example, a Neo Geo cabinet with Neo Geo game boards, or some of the recent Chinese-made multi-game boards. I took the enclosure box apart, and I took out the front panel and marked the position where I'm going to be installing the front 56 pin connector. So I'm going to start drill some holes and cut out that marked section for the metal pins to go through. So it took a little while, but I managed to cut a fairly nice slot in the front panel for the 56 pin connector, and I managed to do it with only minimal blood loss. This happened when the blade of the X-Acto snapped and went flying somehow it landed on my finger. Very exciting. Well, so now what needs to happen is I need to wire the rest of these pins, and once that's done, this thing will get mounted inside of the enclosure along with the power supply right there. Now that I've marked the back panel for all the various sockets and switches that need to go there, I'm gonna start to make the holes also with the X-Acto knife, and hopefully not lose any fingers in the process. So I cut out the appropriate slot for the 56 pin connector, and I also drilled a couple holes. One hole is for the power button, and another hole is for our little LED, which will tell us whether this thing is powered on or not. So I'm gonna show you exactly what the wiring now looks like. I took the power wires and I modified this somewhat, basically by removing the terminal block and soldering the wires directly into the power supply. I'm not sure if you can see that here, but there's simply no room for that terminal block, and it doesn't really add any value. The main problem is that back here I want to mount a little board, which I have somewhere. Where is it? Yeah, it's right there. And this little board will be used to hold our two Arduinos for the Genesis controller interface that I'm going to show you in a bit. And I need the space back here for this. So there was no way to also squeeze in that terminal block, so I left it out and I just soldered the wires directly. We also have our completed harness, which consists of our video wires. Those are the colored wires back there, and the green wires are the control wires for player 1 and 2. So those just go back here, and they're not attached to anything yet, but we'll be doing that soon. As far as the back panel goes, we have our two DB9 male ports. Those are going to be used for our Genesis controller inputs. I made a hole for a DIN socket. So initially what I wanted to do is I wanted to use RCA for our RGB output, but it turns out I'm actually going to need more RCA jacks. I would need 5 simply because RGB is 3. I would need 1 for sync and then another one for audio. So I miscalculated and I just installed 4 instead of 5, which is fine because I can later use these to output component video, which is what we're gonna do in, I guess, part 2 of this project. So for now I'm leaving these unpopulated, but we'll use this one for our RGB video output. And that's basically the same jack that I have on my RGB modded TV. What we have here is our 4 buttons, which are going to be used to coin and start the game. So those are the 2 coin 1 and coin 2 buttons, and also player 1 and player 2 start. And I have my IEC plug with the switch, which now is wired into the power supply. So let's have a quick look at the back. And the back seems to look okay. I think I've done a fairly good job back here. So we have our IEC plug, our switch, the 4 buttons, our DIN socket, and our Genesis controller ports, and our future component video out section. And one of these is going to be used for audio. So next step would be to wire up the video and the audio, and we're going to test drive this thing with my RGB modded TV and see whether we get the right video quality and audio levels out to our TV. So before we wire up the audio and video lines to the TV, let's revisit this chart and briefly talk about the different voltage levels that are present on the JAMMA board output versus what the TV is going to be expecting. As far as the speaker connection goes, the speaker is driven directly by an amplifier that's present on every JAMMA board, and that amplifier is powered by a 12-volt rail. So we can assume that the maximum voltage coming out of that connection will be 12 volts. And if we connect that output directly into the TV, the TV's internal audio amplifier will simply be overloaded, and we'll likely get distorted sound with a lot of clipping, or maybe no sound at all. And there's a risk of damage, of course, to the amplifier itself. So we'll need to attenuate that voltage or that signal down, and we're going to be using a voltage divider with a ratio of 10:1, which should get us approximately 1 volt on the output from 12. So that's the plan right there, and I'm using low resistor values because I want to get the impedance of this output down as low as possible to keep the onboard amplifier happy. Simply because it's used to drive a very low impedance like an 8 ohm speaker, and I just want to keep that impedance on the output low as well, so that there are no side effects associated with hooking this up to an audio amplifier. As far as video goes, the JAMMA arcade game will typically output in the neighborhood of say 3 volts to 5 volts when the colors are fully turned on, the brightest possible colors. So again, it's the same problem as with the audio connection. We simply just can't wire that directly into the TV because the TV will be expecting as a 0.7 volt peak-to-peak signal. And if we overload that, we'll likely get colors that are too bright, or possibly no video at all, and it'll just mess with the black levels within the TV, and it's just probably not going to work very well, or definitely not as intended. So we'll use the same approach. We'll use a voltage divider, but we'll simplify this a little bit because well, for the simple fact that there's a 75 ohm resistor within a TV that's used for termination, and we can use that as part of our voltage divider, and we'll use a ratio of 6:1, which gives us a series resistor of 375 ohms, or whatever's the closest, and by the time that signal reaches the TV, it should be 0.7 volts at that point right there by the termination resistor. And that's true for all the colors, green, red, blue, and sync as well. So we're going to use 4 375 ohm resistors, or well, somewhere in the neighborhood, and if those colors turned out to be too bright or too dark, we may have to adjust this volume. Of course, the other option here is to use a pot and mount a pot to the box, and then that would allow you to adjust the color brightness, but I won't be doing that just because I don't have the room on the panels anymore. I ran out, and I'm not going to be opening this thing up to adjust the brightness for each game. So I'm hoping to just stick with the one type of resistor and get this working this way. So I connected the Mortal Kombat and powered on the Supergun. And while the video seems to look alright, the colors are bright enough, and everything looks okay there. I can confirm that there's definitely a problem with the sound quality. So first of all, there's a clear hum that's present, and also the audio amplifier on the board gets pretty toasty, and I'm pretty sure something is wrong with my assumption of using those values for the resistor or the voltage divider. So I'm gonna have to revisit that and see exactly what's going on, and come back and test this out again and see if I can improve the situation. But video seems alright. Colors are maybe a little bit too dark, and I use a 390 ohm resistor, so maybe using a 365, which is the next closest value, would have been a better choice, but this is all right. This would work just fine. So I'll probably keep everything as is with the video and just try to figure out what the problem with the sound is. I found a circuit that seems to work quite well for the audio output section of our supergun device, and if you remember, before we used the 10:1 ratio voltage divider with a resistor of 100 on top and 10 ohms at the bottom to form that ratio, and when using this I noticed that we had some overheating issues with the onboard amplifiers, the game amplifiers, and also that there was some sound distortion. So I looked at the possible causes, and one was that the path to ground, the impedance of the circuit was most likely too low. And the reason for that was that there actually is a termination resistor behind the RCA jack of the TV's audio input, and while the service manual doesn't exactly specify the value, I have a feeling it's probably about 75 ohms, just like the other termination resistors that I use in the video section. So then I thought, well, we can just use this in conjunction with a resistor here and get ourselves a 10:1 ratio, which is something very similar to what we did in the video output circuit. So when I did that, that actually worked quite well, and it took care of the distortion and the overheating. But when I tested some games, it turned out that I was getting no sound at all, or very faint sound. And the reason for that is that this particular pin, the speaker minus pin, isn't necessarily tied to ground. It may be floating above ground, or it may actually be reversed. So I have a couple of boards where the speaker plus output pin is actually tied to ground, and the speaker minus pin has the signal out on it. So then I thought, well, why not just combine these together, create another voltage divider, and then we can feed that output to the TV. And then using a 650 ohm resistor in parallel with a 75 ohm resistor gives us about 65 ohms, give or take a few. And 650 with a 65 ohm, that's a 10:1 ratio. So that gives us exactly the type of attenuation that we're looking for. And I tested this particular method with a number of boards, and haven't found any issues at all. So this would probably work quite well in, I would say, the majority of the cases, if not all. Now I should probably mention one more thing, and that's stereo sound. So in most games that output stereo, the speaker plus pin is used for one channel, the speaker minus is used for the other, and there's a common ground that both of these used, and that's how you get the stereo sound. There are other ways other games use the pins, not connected pins that are adjacent to the speaker pins, and there are other games that use a separate header for stereo sound. But if you have a game like this that outputs stereo, this will actually work for that game, because what it does is basically just mixes the two outputs together, and in conjunction with ground, you're gonna get one single mono output. So I have here a cheapo Arduino Nano. These things are maybe $3-4 shipped from AliExpress or eBay. And I made a little test harness to interface this thing to a Sega Genesis controller through a DB9 male socket. Now let's talk about this thing right here. Most of the time I would use a different microcontroller for a project like this, maybe a Texas Instruments MSP430, but this one is actually perfectly suited for this project, primarily because this is a 5-volt logic level IC, so it'll interface with the Genesis controller perfectly fine, which also requires 5-volt levels, TTL levels. Also, these are fairly popular and quite easy to program. So for you guys out there that want to replicate this this project and create your own device, I'll make the code available so you can download it and create your own interface to a Genesis controller. And what I have here is just the old style 3-button plus the start button Genesis controller. I don't actually have a 6-button controller at the moment. At least I don't think I do. So we'll use this one here. This will work just fine. It has the 3 buttons plus the start button. So that will cover most of the arcade games. Like I said, most games out there use 4 buttons or less. So this is perfectly fine. But I'm thinking of using something special here, and I'll talk about that in a second when we walk through the code. But should be able to get 5 buttons out of this. I'll show you how in a second. Okay, so let's walk through the code and I'll show you exactly what I mean. I want to mention one other thing here. The reason for using these Genesis controllers is because these are quite readily available. I mean, these things, the knockoffs at least, are cheap as dirt, and a DB9 interface for joysticks is also common as heck. So you can use other pads like the Sega Master System pad, or just a different joystick, a 2-button joystick that would be compatible with this controller. So that's why we're sticking with this, and that's why we're going to be using it for this project right here. Okay, so let's go through the code, and I'll explain what the code does, and like I said, I'll provide a link for you guys to download it. So here's the Arduino code that I wrote for the Genesis controller interface. Let's first spend a little bit of time talking about the operation of the Genesis controller. So the Genesis controller is actually backwards compatible with the old style joysticks that were just switches and didn't require power. And what I mean by that is you can basically leave out the 5 plus 5-volt pin and the select pin and wire up the up, down, left, right, B, A, and C start pins to your game, and this controller would work just fine, but you'd only get the 2 buttons, button B and C. What happens with the actual Genesis is the Genesis console will toggle the select pin. It will toggle it high and low every so often, and when this pin or this select line is high, you'd get button B and button C state on these pins. If the select pin is low, what you end up getting is the state of button A and also the state of the start button. So that's how the Genesis gets to see the 4 buttons on the controller, and that's what we're going to try to do. We're going to toggle this pin, and then based on the state of this pin, we're going to read the buttons and map them appropriately to the output pins, which are going to be connected to our game board. But like I said, you don't need an Arduino. You can just simply wire up these pins to the board directly, and you get the 2 buttons. So this section of the code right here is just a map of all the pins and just an alternate label for each one, so that when we look at the code below, everything's making sense. We're not going to be using labels like 13, A0, A1, A2, which are going to be difficult to read. So I renamed everything. I gave each pin an appropriate function with an alternate label, and like I said, that's just going to make the code easier to read. Okay, next up, we have our select variable, which keeps track of the select line, and I have a little additional logic that I created. I'm going to start a counter when the start button is pressed, and if you hold it for a certain amount of time, which is defined right here, it's 100 loops basically of the loop function. What will happen is this pin right here, the button start pin, will go low, and that will trigger the game to start. So that's how we're gonna get the 4 buttons. So basically the start button, if you just tap it, that button will act like the 4th button, and when you hold it, it's gonna act like as if you press the start button. The setup section is very straightforward. What it does here is we take every one of these pins and assign them either an input or an output function. So our pin select, which is used to tell the controller whether we're interested in button B or A or button C or start, that's our output pin. And of course our up, down, left, right, button C start pin, button B A pin, those are all going to be input pins. And then our output section, so we have our up, down, left, right, which will be wired into the game itself. And of course, in addition to that, we have the button 1, 2, 3, 4, 5, 6. 5 and 6 we're not going to be using. And our start button, those are going to be wired to the game. Let's go through the loop section, which is our main logic for this controller. So the first thing that happens is we toggle the select line. This just toggles the variable, but basically if the variable was a 0, we set this to 1. If it was a 1, we set it to a 0. And then what we do is we write that value, the 0 or 1, from the select variable to the pin select line. And we follow that with a bit of a delay, just to let things settle a little bit. So here I left a comment for the behavior of the controller. And now we can talk about the rest of the code. So as I mentioned here, for up and down is up and down regardless of whether select is low or high. So this section right here is basically just taking the values of this pin here. So we're reading it and then we're writing it out to our output pin. For our other pins, what we do is if the select is high, basically what we do is we take the button BA pin and we output it to pin 2. Okay, so that kind of corresponds to this. So if we have our BA pin, if the state is high, we take button 2, which is B, right? So button A would be button 1, button B would be button 2, and button C would be button 3. So that's what we're doing here. So we take this pin and we map it to button 2. We take our C button when the select is high, which is right here, okay, and we map this to button 3. Now obviously during the select high portion, the left and right signals are present, so we also take these here and we map them to our output pin. Okay, now if the select pin is low, right, we take button A and we take the start button, right? So what we do here is we read that button BA pin and map it to button 1, which is A, and we take the C start pin and map it to button 4. So start is our button 4, and this only can be done during select low portion. Now you notice that I didn't include the left and right here in this section because of course when the select is low, we only have 0 or low on these pins, so that's not usable. We don't want to copy those values at that time. And the remaining portion of this function is basically to deal with the counter and the holding down of the start button for to create an additional button. So basically, if you hold this button, the counter starts to increment, otherwise it resets, and once it passes the start hold ticks value, which is defined above, it will actually set the pinout button start pin to a 0, which will turn on our game or start our game. So now I got the controller hooked up to the Arduino, and the Arduino is hooked up through a USB cable to the laptop, and I got the serial console running right now so we can see exactly what the controller is doing. So let's talk a little bit about what's on the screen. The first letter is the state of the select line, so we can see that it's toggling between high and low, which is exactly what we expect it to do. And following that, we have the input section. So those are the values read from the controller. Pins are up, down, left, right, and a button B/A pin and button C/start pin. So when I press up, down on the controller, you can see those going low. LR is obviously only active for half the cycle when the select pin is low, so we can expect it to go low for the high portion of select. And then B and C obviously respond accordingly, and those only go low for half the cycle, of course, when select is low. So B and A go low for the opposite side of the cycle. If I press both of them together, both B and A are triggered, which means that the B line is completely low for this for both sides of the cycle, and then same thing will happen when C and start is pressed, right? Okay, and then that is followed by the output section. So we have our up, down, right, and left, and when I press up, down, left, right, so those are the mapped values following the logic that we set up. And when I press A, button 1 is triggered. When I press B, button 2 is triggered. C, button 3, and then start is our button 4. Now here's the start logic. So when I hit start, it triggers that counter that we talked about. Once that counter reaches 100, it activates our start button. Okay, so that's it for the debugging. So you can see everything is working as expected, and I'll basically go and wire this thing up to the supergun device that we're building, and everything should work as expected. I created this little board, which is where the two Arduino Unos are going to be mounted, one of course for each controller, and other plugs here are for power, and this is power output that will go into the DB9 connectors. And all it is simply just a series of female headers where the Arduinos are sitting, and male headers that are just connected to the appropriate leg on the Arduino, and just the two power wires, nothing else to it. And these will be mounted in the space where the 4 standoffs are currently. So I've already drilled the holes and got everything set up so that this thing can be mounted in place. And of course I also got the plugs already wired from the JAMMA connector side. So the only thing left to do is just to solder a bunch of these wires to the DB9 ports and connect them to the Arduino board, and mount everything in place. Before completing the project, let's make sure everything works, and for that I hooked up my SNK versus Capcom Service Chaos board, which is basically just a Neo Geo with one game built in, and I set up the test menu so we can make sure that the controls all function as expected. So I got my both Genesis controllers plugged in, and you can see up, down, left, right, button 1, 2, 3, start, and then if I hold start, oops, that takes me out of the menu. Okay, so let's go back in there again. The date is all wrong, of course, but that's fine. Okay, so here we go. So we got up, down, left, right, button A, B, C. Start is button D. Let's do this on the second controller right here. We got up, down, left, right, A, B, C, start. And if I hold start, I get the virtual start button. So everything seems to work, and let me now go ahead and show you the completed wiring inside of the enclosure, and let's finish this up. And here's the completed wiring. We have our power wires, which is a ground, our +5, +12, and our -5. Those are just simply soldered directly into the power supply. Then here, the next two wires, the green and the black, those are the speaker wires. They make it all the way back to the panel, to the bottom RCA jack there, and the series resistors are attached to the jack as well. It's kind of difficult to see, but they're behind that heat shrink tubing shell. And same thing goes for the video wires. So we have our 3 colors RGB and our sync, and those again make it back here, and they're attached to the DIN socket. So as you can see here, you can see the resistor outline, and those are the series resistors for the attenuated video signal, and those are just soldered directly into the DIN socket, as is the wire. Wire just soldered to the resistor itself, and they're pretty well attached with the heat shrink tubing. Is going to protect them from shorting out against each other and keep everything solidly mounted. Then we have a couple of blue wires back there. Those are the test wires, so service and test switch wires. I didn't actually connect them to anything yet. They're just kind of sitting back there tied together. I may repurpose the start button later on, and I may attach these start buttons to the test switch function. We'll see. I haven't decided yet, but so far everything is there, and it's ready to be used if I decide to do that. And then finally we have our controls. So we have the green wire section. Those are the joystick controls, and then the buttons are back here. I mounted I soldered these wires to the 5 buttons on the edge connector. Even though JAMMA standard calls for 3, I mounted all 5, and later on I can, when I expand this thing to allow for 6-button play, everything will be ready. Anyway, those just go back out here, and they actually are attached to the Arduino board. So this is the output. We have our directions here and the 5 buttons, I guess, and this Arduino right here. So this connector is player 1, which is the back Arduino, and then player 2 is attached to this one here. It's the front one, and those are just simply copies of each other. They run the same code because the behavior of both joysticks is identical. So that's what I did back there. And of course the input section, so these DB9 ports are soldered to these wires, which are going to the input section of both of those Arduino ports. And what else? So we have the 2 switches back there, our start switches. So these are connected through those green wires to the edge connector, but also there is a wire that goes to the last pin of the Arduino, and if you remember, that's the start button function. So when you hold the start button on the controller, it triggers the start pin to go low, and since this is connected to the start button and the start button is connected to the edge connector, it basically has the same function as pressing the start button, which just starts your game, right? So like I said, that may be it may be unnecessary now to have the start buttons here, and I may just use those for a test function, but for now I'll leave it as is. It's just easier to test the game. I don't have to plug in the controller. I just push the start button, and it works just fine. So, but like I said, this is a dual purpose wire, right? So the start button can be triggered from both the controller and from the back panel. And below is the two coin buttons, and those are wired again through these green wires directly to the back panel as well. Sorry, to the front panel edge connector. And there's a there's a black wire, common ground wire, which is connected to all these switches. And last but not least, I just took the IEC plug ground and I grounded the power supply. Not really necessary, but I figured I'd do that for safety. And I should probably mention here that I tried to tie everything together, keep everything solidly in place so it doesn't flop around too much, and tried to keep all these wires away from the heat sinks, which are likely to get hot inside this enclosure when it's closed. And just want to make sure there are no accidents, the wires don't touch, and they don't get melted in the process and short things out. So that's I may have to do something with these wires. They flop around a little bit too much, but anyway, that's the whole thing right here. And oh yeah, I should probably mention just a little LED with a series resistor inside of the heat shrink tube, and that's that just soldered directly into the power supply as well. So this is the finished wiring. I know it's a little bit of a mess. I actually didn't expect this project to be so time consuming. I underestimated this a little bit, but yeah, let me put on the shell and show you what this thing looks like with the top on. And finally, here's the completed supergun device. So I have to admit, I'm pretty happy with the end result. The project, even though is a little bit time consuming and took a little bit longer than I expected, it went fairly well. There were not too many issues along the way. I didn't break any games in the process, and yeah, I'm like I said, I'm pretty happy. Everything looks nice and neat. The front's got a new label on it, and the back looks nice and neat, and most of the functions have been implemented, maybe with the exception, of course, of the component video, which we'll try to do in part 2 of this project. So before we wrap up this very long video, let's talk about a couple things. I built a box like this many years ago, and while it wasn't much simpler, the box was a little bit different. It had composite video and different controller interfaces, because Arduinos were not available back then, and neither were TVs that could display component video. Well, maybe there were, but they weren't very common. So back then, when I built something like this, I didn't remember it being very time consuming. Maybe I took a little bit of additional care this time around, and of course making a video takes a little bit longer as well. But I'm pretty sure that you'd be able to basically take the information from this video and put something together, put something like this together in, I would say, maybe half the time that it took me. Mainly because the interface for the Genesis controllers took a little bit longer to develop, and of course I'll just provide the links to you guys for that if you want to build something like this yourselves. And another thing I should probably mention is don't get an edge connector that is bare. So this one, if you remember, this just had a bunch of pins sticking out the back, and well, I did have a few wires attached to it. I had to pretty much solder the entire thing. But there are options. You can get get an edge connector that's already pre-wired, has all the wires attached to it, and everything is labeled for JAMMA. So if you do get one of those and use that instead, you already have everything pre-wired, and you won't have to solder at least this half of the wires, so it'll save you at least half the soldering time, and you won't have to get additional wire as well. So while it may cost you a little bit of extra money, I think it's a worthwhile investment. So next time I do this, I'll probably just end up getting a pre-wired harness. What else? There may be a couple things that I would do to this a little bit differently this time around. When I was testing this thing, the heat sinks inside were getting a little bit toasty, and an ATX power supply, which is what I'm using inside, has a fan blowing air over those heat sinks. And here, this is just a closed box with no ventilation or airflow. So this is something I would be looking out for. If you find that your power supply is getting a little bit too hot, maybe I would put additional space around it, or possibly install a fan, which is probably what I'm going to do next. Really just hopefully you guys will take this video and follow the advice I gave you, and if you decide to build something like this yourselves, you'll find considerable savings, time savings in the advice that I provided you. So before we wrap this up, we'll split the video up into two parts. In part 2, we're going to deal with 6-button controls, which typically require an additional wire harness, and we're also going to look at the implementing component video, and maybe talk about putting it composite and as video outputs as well. And we probably should also talk about stereo sound in part 2 of this video as well. So let's wrap this up, and like I said, I'll post part 2 of this video shortly, and hopefully you guys have enjoyed this so far. Okay, so that's it, and good luck building your own. And now, to celebrate the end of this project, let's play this video out with a quick round of SNK versus Capcom SVC Chaos. That pronunciation was spot on. I was hoping to do a little bit better. You know, I'm not really used to this weird controller layout. Keep getting mixed up with the buttons. Well, anyway, that's it for this one. So I hope you guys enjoyed this, and hopefully it convinced you to build your own super gun and get into the collecting of arcade games. So like I said, this is it, and if you enjoyed this, make sure to leave me a like or subscribe, and I'll see you in the next one. Bye everybody.